So good morning, everyone, and welcome to this roundtable discussion organized by the social statistician of the Department of Statistical Science of the University of Padua. I'm Giovanna Boccuzzo, professor of social statistics in this department. We are very pleased to welcome today Professor David Bartram. Thank you, David. Along with Dr. Paola Annoni and Dr. Elisa Cisotto and our Bruno Arpino. So this initiative was inspired by the editorial written by Professor Bartram and his fellow editors on the occasion of his appointment as editor-in-chief of Social Indicators Research. The editorial touches on many key issues relevant not only to social statistics, but to quantitative research more broadly. For instance, estimating causal effects using observational data, measuring complex and multidimensional social phenomena, evaluating the practical significance of findings, not just statistical ones, and many other methodological considerations. These questions are particularly relevant today at a time when machine learning and algorithmic approaches increasingly guide decision-making processes in both research and policy contexts. So while these tools offer powerful capabilities, they often prioritize prediction over explanation and leave limited room for critical reflection on research design and methodological choices. Engaging with foundational issues, such as how we define variables, identify causal relationships, or assess the practical relevance of our findings, is essential to ensure that quantitative research remains rigorous, transparent, and meaningful. So we thought that this discussion around these themes will be both timely and thought-provoking, not just for social statisticians, but for researchers across various disciplines. To enrich the conversation, we have invited several colleagues to contribute, each bringing a different perspective on social research. So let me briefly introduce our guests. David Bartram is a sociologist at the University of Leicester. He is editor-in-chief of Social Indicators Research and vice president of the International Society for Quality of Life Studies. His previous roles include co-editor of the Journal of Happiness Studies and president of RC31, the Sociology of Migration section of the International Sociological Association. He has received research grants from the British Academy, the Economic and Social Research Council, the Leverhulme Trust, and the Nuffield Foundation, and holds a PhD from the University of Wisconsin-Madison. Paola Annoni is an analytical team leader at the European Commission's Directorate General for Communication Networks, Content and Technology. Sorry, Paola, so long name. She specializes in data-driven policy design, particularly in the fields of the youth digital economy and regional development. She leads a team that develops analytical frameworks to support policymaking, including the monitoring system for the Youth Digital Decade Program, which informs strategic decisions across member states. With several years of experience at the Commission, Paola bridges the gap between institutional practice and academic research, and she will offer valuable insights into the role of social research in policymaking. Elisa Cisotto is a researcher in social statistics at the Faculty of Psychology, Catholic University of Milan. She holds a master's in demography from the University of Barcelona, a PhD in demography from Sapienza University of Rome. Her research focuses on population aging, care dynamics, and intergenerational exchanges, with a particular interest in the social determinants of health. Actively engaged in international collaboration, she is part of the coordination team of the Longevity and Aging Laboratory, called LOLA, and of the Young Social Statistics Lab, GLASS. Today we have very members of GLASS. Today, she will be speaking on behalf of GLASS, providing a perspective from the younger generation of social statisticians. And finally, Bruno Arpino is full professor of social statistics here in the Department of Statistics. His methodological work focuses on causal inference and the application of machine learning techniques in the social sciences. Substantively, he studies topics in social gerontology and social demography, with a particular focus on family relations, the health and well-being of older adults, and the use of digital technologies in later life. Bruno combines methodological and substantive expertise, and I'm sure he will bring insightful reflections on methodological challenges in quantitative research. So, before giving the floor to our main guest, let me briefly explain how the session will unfold. Professor Bartram will deliver the keynote presentation, followed by brief responses and one question from our other guests. After that, we will open the floor to questions and comments from the audience. And finally, Professor Bartram will respond to the points raised during the discussion. Hopefully, we are able in almost 2 hours to conclude all these steps. So, and then at the end, we go to the garden to enjoy lunch together. So, David, thank you very much for being here. The floor is yours.
Thank you. Thank you, Giovanna. Thank you to you and to Bruno again for this invitation. I'm really grateful to be here. So as you'll see, I've advertised. When I was reflecting on what I wanted to say and how to capture it, it occurs to me that what's most important about what we're trying to do with research in general, but in the context of quantitative research specifically, is to gain insight into the social world. So it's not that rigor isn't important. Rigor is, of course, important, but rigor serves a purpose of creating research that actually leads to insight. So that's the key message I want to lead with. And I would then suggest that there is quite a lot of research that gets produced, and maybe even research that gets published, that maybe doesn't produce a lot of insight, possibly even rigorous research that doesn't lead to insight, perhaps because it simply isn't discussed with that purpose. So again, I want to emphasize the ultimate goal here. Rigor is important, but again, it serves a deeper purpose. So what I'm going to do in the talk is to highlight some practices that some researchers engage in, perhaps without giving them all that much thought, and then maybe the research doesn't lead to insight. And I'll use those reflections as a foundation for suggesting some ways of approaching quantitative research in ways that lead us to conclude, to have confidence that we've actually learned something, either from actually doing the research or maybe indeed from reading other people's research along these lines. So I want to start with a slide that, I'm not advancing that way either. Sorry. Might need a little bit of help. Oh, there we go. Got it. I just used the space bar. All set. That's fine. Thank you. So there's an example of what we might see in a manuscript or a published article. It's entirely conventional. I've chosen it almost at random. It's a little bit unfair to single out this particular study. So I'm not giving any details on it, where it comes from. I would ask you not to look for it. It is entirely conventional, and it's just an example. And I'd like to draw your attention to certain elements that might be entirely conventional in ways that we might not really think all that much about. So what we have here is a table where the title of the table is Predictors of Quality of Life. The words there might be a little bit small, but at the top it says Predictors of Quality of Life in a particular location. We then have a number of variables that we're meant to understand as predictors. We've got the coefficients, we've got the standard errors in parentheses, and then we have asterisks. And what we're meant to understand from the asterisks is that the variables where the asterisks are present are going to be significant predictors of quality of life. Now, I'm highlighting all of these elements of the table. I don't really need to. I would imagine everyone in this room is familiar with those elements, but I'm highlighting so that then I can pose some questions. Why would we care about prediction? And in fact, do we care about prediction? Maybe we do, but let's make sure that we understand why we would care about prediction. That's the first question. The second question is, what do we mean by significance? And what do the asterisks really convey? Why do we use asterisks? And what are we meant to understand from them? What are they meant to tell us? And then the third question is, what are all these variables doing in a single model? Now, you might think those are questions that don't really need answering because it's obvious. But of course, part of the purpose of my talk is to suggest that we might find value in doing a little bit more thinking about those elements so that we don't simply take for granted what we think of in conventional terms as obvious, so that then we can perhaps think more deeply about the kind of results that we get from research in this particular mode. Okay, so I'm taking an entirely conventional example and then suggesting, let's think a little bit more deeply about each of those elements that we might think of as conventional. So what I'd like to start with as a way of moving towards some reflections on these conventional modes of doing research is that we might not really care as much about prediction as we conventionally do. And maybe you don't use the word prediction in your own research, but it's conventional for people to do that and to think about the variables that go into a model as serving the purpose of prediction. So I'd like to start from the opposite premise, a different premise, which is that causal relationships are very likely the kind of insight that we likely want. We might feel a bit uncomfortable about it, okay, partly because we're led to understand causal identification is difficult. And we might then want to take care in terms of how we interpret our results. So we might use the word predictors or prediction as a way of just being a little bit more careful, more cautious about the work we're doing, and then how we're going to present it, how we're going to interpret the results. So that's fine. We might indeed want to be careful, but I would nonetheless suggest that causal relationships, causal effects is likely the information that we really want. And if we do want it, then I would suggest that we want to be more explicit about it. We want to embrace that purpose of doing quantitative research so that we can then think, what does it actually require? So instead of hedging or simply exercising caution and using the language of prediction in a way that enables us to do this sort of work and present it in ways that won't, so to speak, get us into trouble. Instead of doing it that way, instead of being cautious, if we really want to do this sort of work that leads us to results that we can interpret in causal terms, then let's be explicit about it. And again, I think it is what we typically want. I think our intuition about how the world works includes the understanding that there are indeed causal effects out there in the world. This is how the world works. If you walk in front of a bus, the bus is going to cause damage to your body. Now, that's an easy example. It's not the sort of thing that we would embrace in the context of quantitative social research. But even when it comes to the social world, or the economic world, or the political world, our intuition tells us that causal relationships are how the world works. If American voters vote to elect Donald Trump as president of the United States, certain consequences are going to follow from that act, from that choice. And then we're going to want research that helps us to understand what those causal impacts are. So if we think we want prediction, then okay, but let's make sure. And if instead what we want is research that gives us causal effects, then let's acknowledge that and then do the work in ways that actually give us what we want. Now, there's another way that I like to make a case for thinking in terms of quantitative research that actually explores causal impacts. Now, this example, what I'm about to say, I suspect that it really only works in English. I don't think the language, the words are going to work the same way in Italian, but it does work in English. So we might pose a research question that starts with the word why. Okay, why does something happen? Why do we see the patterns that we see? And then in English, if we ask a question, a research question that starts with the word why, we are going to be led in many instances to give an answer that begins with the word because. Okay, why are things this way? Because of whatever we think the answer is. And then what we have, possibly something that you might not have noticed about the word because. The word because contains the word cause. Okay, causal. Now, maybe that's a little bit cheap as a way of validating our intuition, but it is certainly in line with our intuition. I think this is often what we want. If we want prediction, if we think we want it, then that's okay. Maybe prediction is going to be useful, but we would certainly want to know why prediction would be useful. Do we actually want to use a model that we create for the subsequent purposes of predicting outcomes under certain conditions with certain values of the variables that have gone into that model? If that's what we want, fine. But I suspect in many instances, that's not what is happening when we create a model and then we describe what it gives us using the language of prediction. So I'm going to move forward on that basis, that typically what we want is causal analysis, not prediction. I'm going to use a number of examples that come from the research that I typically do, which pertains to happiness. We could ask, why are some people happier than others? That's the sort of example that I would do in line with my research. But I'm going to be a little bit more specific about it for reasons that will become clear. I'm going to pose questions, think about research that poses questions that ask about the specific impact of a particular variable. What is the impact of some variable on people's happiness? So I'll do that in ways that help us to gain some clarity on how we would do research that is going to give us what I think we would want. Now, the first topic that I'll explore is the logic of selecting control variables. I'm taking all sorts of things for granted here. I think I don't need to set up the work that I'll do in the context in other ways where I'm explaining other components of it. Instead, I'm assuming that we're going to construct a model of some sort, likely a regression model, and we are then going to construct that model in ways that's going to use control variables. And what I want to then bring to the surface is that one of the things that, in my view, doesn't involve a great deal of thought is how we make decisions about selecting the control variables that then go into our model. So if you're doing this work yourself, but let's talk about the work being done by others. If you're reading published quantitative research, and you were to look for an answer to this question, how did the researcher that did this work, how did they decide which variables to use as controls? Okay, and in particular, what criterion was used to inform those decisions? So not just the variables that they selected as controls, but the logic of it, the criterion that they used. What you would almost certainly find in most published research is a criterion that amounts to thinking in terms of the other determinants of the dependent variable. It might not be articulated in those terms. Sometimes it is. Okay? If somebody is articulating a criterion, then what they're likely saying is, I need to control for other determinants of the dependent variable. So if we're thinking in terms of the impact of X on Y, what we have in this particular screen is a representation of the idea that we would select as controls other determinants of the dependent variable. The dependent variable on the screen here is, I've got these letters, SWB, that stands for subjective well-being. And then we have happiness as a form of subjective well-being, or perhaps life satisfaction as a form of subjective well-being. What the diagram gives us is a number of variables where we have arrows running from left to right. And then what we understand is these are some of the typical determinants of subjective well-being, happiness or life satisfaction. And then what would happen if we actually had a representation? Typically we don't, but I'm trying to represent the thinking that many people do. What we would then have is, if we have a research question that asks about the impact of any of those variables, so in other words, highlighting a research question that asks about the impact of one of them on happiness, what would then happen is the researcher is going to then decide, well, if I want to know the impact of one of them on happiness, then I'm going to need to include as control variables all of the others that appear in this diagram. So if I want to know the impact of people's social capital, the one at the bottom left there, if I want to know the impact of social capital, then I'm going to include all of the others as controls in the model. If I want to know the impact of education on people's happiness, then I'm going to include as controls all of the other variables that appear in this diagram. Whatever the research question is, many people are going to, on the basis of this understanding of selecting controls, they're going to include all of these variables in the model. That's what this criterion tells us to do. We have a research question that asks about the impact of one of them, but we then need controls. Which controls? The controls are going to consist of all of the other determinants of the dependent variable, happiness. So in essence, we would have the same model. No matter what the research question is, we would have the same model. All of the same variables in that model, or perhaps even other variables as well. Now you can probably guess, I think that's the wrong criterion. It's the criterion many researchers use, but it is in fact the wrong criterion. What we need is to think not just about the variables that affect the outcome. We need to think about the relationships among all of the variables that might go into the model. Now, of course, we can, if we put both of these representations on the screen, we can see that they're quite different. The one on the left just asks about the relationship between the independent variable and the outcome. The one on the right forces us to consider quite a lot more information. What is the relationship between each pair of variables in this model? Now, that's a lot of information. I'm not going to try to explain everything that appears in that right-hand diagram, but I am going to suggest that if you want to do this sort of work effectively, there's quite a lot more exploration that is going to need to be done. So what I'll do to start to lay out the logic here is to offer a sort of a toy example, a very straightforward example, the sort of thing you might expect to find, maybe you've seen in a statistics textbook. And it's partly intended to help us move from a simplistic idea, the idea of correlation, the correlation between how tall somebody might be and their intellectual skills, captured in the question of the number of words they can use, the size of their vocabulary. So I've got a correlation on the screen. Okay, how tall somebody is, that's correlated with their intellectual skills, how many words they can use, the size of their vocabulary. That's a real correlation. Taller people use a larger number of words. But of course, correlation isn't causation. So the idea that we draw an arrow from one to the other, that's a misrepresentation. Correlation is not causation, but they are in fact correlated. Taller people use more words. If we want to understand whether it's a causal relationship, we can interrogate that correlation by using control variables. The control variable that we would need in this context is age. And what we can now understand is that we're talking about children. So it's taller children that use more words, but being taller doesn't matter for the size of their vocabulary. When we control for age, what we now understand is that it's age that has the consequence of leading children to use more words. Age, getting older, also leads children to become taller. And then when we control for age, what we then see is that there is no relationship between height and how many words somebody uses. Okay? Being taller, getting taller doesn't lead people to use more words. So we've used control variables correctly here, but the key observation to bring to the surface is that we've used the right control variables, indeed the right control variable, the right one, and we've done it by way of ensuring that the control variable we've used is an antecedent, not just of the outcome, but of the independent variable as well. Age is what leads people to learn to use more words. Age, getting older, is what leads people to become taller. And if we do it that way, then again, we see there's no causal relationship and no important correlation between height and vocabulary. So all of that might seem really quite straightforward. Does it really need articulating? Well, it might need articulating. Let's take another example. What if we were interested in seeking the impact of unemployment on people's happiness? Does losing your job lead you to become less happy? Well, the answer is likely yes. But if we thought that we needed to identify control variables in the mode that many people do it, in other words, we're going to control for all of the other determinants of happiness, we might be led to include income as a control variable. And that's what we get in the context of the representation that I had on an earlier screen. If we think we want to, if we want to explore the impact of unemployment on happiness, then we need to include all of the other determinants. Income is one of the other determinants of happiness. So we might be led to include income as a control variable. But what we now have is a question and indeed a problem. Does it make sense to draw an arrow going from income to unemployment? Okay, that's not a question you would ask with the graph, the figure at the bottom right here. That question isn't raised in this graph, the one on the bottom right. But we can, of course, ask it. Does earning higher income, or indeed lower income, does it lead to an increased probability of unemployment, of losing your job? Is that the way we would draw the arrow between income and unemployment? And what I would then propose is that the answer is no. Instead, the arrow between income and unemployment should be drawn in the other direction. When you lose your job, your income goes down. With the lower income, you're likely to be less happy. Unemployment might also make you less happy. But what we now have with a different pattern is a different decision on whether we would control for income if we wanted to estimate the impact of unemployment on people's happiness. If we included income as a control with this understanding of the relationship between income and unemployment, what would that mean? What would the model give us? What it would give us is a comparison of happiness for employed versus unemployed people, but we would be controlling for income. In other words, we would have that comparison among people unemployed people and employed people who are earning the same level of income. And we would be holding income constant. And we would then have to ask, is that the right estimate? Is that going to give us the impact of unemployment? And the answer surely has to be no. It's not the right estimate. It might be what we could call the direct effect of unemployment. There would then be an indirect effect of unemployment that goes through the mechanism of income, the way unemployment, getting sacked, lowers your income, and then the reduced income leads to lower happiness. We would have an indirect effect of income, but the model that is created with that control variable, it doesn't give us that indirect effect. It gives us the direct effect. So it doesn't give us the total effect. We can then ask, does this make sense as a way, as a starting point for estimating the effect of unemployment on people's happiness? And the answer is, it doesn't make sense. It might make sense if we're then going to explore mechanisms, but what we surely want first is to estimate the total effect of unemployment. After we know what the total effect is, then we can estimate mechanisms, explore mechanisms. So let's step back from all of this. And again, I accept this might be something that is on board. People in this room, you might already have awareness of this. That's fine. I would hope to learn that that's true. But I can promise you that in manuscripts submitted to the journal where I'm editor, and even in published manuscripts, there are quite an awful lot of people that don't understand what I've just said. Okay, so maybe even people in this room, perhaps there's some benefit. So let's articulate the general principle that we get to by virtue of exploring the different criterion for selecting control variables that I've just articulated. So not just controlling for other determinants of the dependent variable, but instead looking at the relationships among the various independent variables that we might want to put in the model. What we want is control variables where you would draw an arrow from the control, not just to the outcome, but also an arrow from the control to the focal independent variable. So if we want to know the impact of X on Y, we need controls where the arrow goes from the control to the independent variable whose impact we are seeking to estimate. We then want to avoid controls where the arrow goes the other way. If we're drawing an arrow from X towards W, then we're doing it wrong. And I've used W for this purpose, W as a letter to denote control variables, simply because as a matter of the alphabet, W should come before X. If W is coming after X, if we're drawing an arrow from X towards W, that's an indication that we might be doing it wrong. Doing it wrong in the sense that if we do it that way, we're going to get bias in our estimation of the impact of X on Y. There are other possibilities. In particular, perhaps there's no relationship between the potential control and the focal independent variable. Here we can say that the control is irrelevant to the estimation of x on y. We don't need it. It won't necessarily do damage, but we don't need it. But the key thing is to avoid what is described, not by me, these are well-established ideas. We want to avoid what is known as omitted control, over control bias. Our general concern, the concern that many people have, is that we want to avoid omitted variable bias. And that's a proper concern. But what I'm doing with this screen in particular is to raise the possibility of what is described as over-control bias, which is a less familiar term. Now, there's a number of implications that follow from this alternative way of thinking about control variables, where our purpose is to estimate a causal impact. One implication is that we can't just use one model to estimate the impact of every variable that is going to be in that model. Here's a bit of information. If you did a search using the titles, okay, a Google Scholar search where you specify a term that you want to appear in the titles of published research, if you do that search, okay, a title search, the determinants of, you will get a set of results that is estimated to be at least 430,000 results. There are at least 430,000 published articles that use that phrase in the title of the article. That is, in effect, what we see in the model that I started out with as an example, where somebody is using the language of prediction. They likely want to know not prediction, but instead the causal effects of all of those terms in the model, the variables in that model. So they're going to interpret each coefficient in causal terms. They're going to do it by way of significance. Every variable that has asterisks in that table is going to be interpreted as a significant predictor of quality of life. But what they likely mean is each of those is a significant determinant of quality of life. But if they interpret each of those results in that particular sense, then what it amounts to is a pattern that has been usefully described as the table 2 fallacy. Interpreting all of the variables in a model as determinants of the outcome via statistical significance. So they are now the significant determinants of the outcome. What we have with that piece of research published more than 10 years ago is identification of a pattern which says that it's a fallacy to interpret all of the results in a model in those terms. It's a fallacy, and yet very large numbers of studies have been published in this mode. So I'm not going to explore more deeply. I want to move on to discuss some other ideas, but there's something that you could explore. If the term, the table 2 fallacy, isn't familiar, then I would suggest looking for it. And again, if you want to see the dimensions of the fallacy in operation in published research, then you can do that Google Scholar title search, and you'll find many thousands of results. So that's one implication. You can't use a single model. You need different models depending on what your research question is. Another implication of this way of thinking about control variables, this different way, is that you need to engage with previous research. Of course, we always engage with previous research about the dependent variable. But what we now understand is that we need to engage with previous research also about the focal independent variable. That's what we learn from this particular representation of how we need to identify control variables. Okay? We need to understand the relationships between the potential control variables that we might be thinking about putting in our models. Which way would we draw the arrows? And of course, what I've given you is a set of decisions. I've drawn the arrows in one particular way, and that perhaps makes it look a little bit easy. But what we might have to think about is maybe it isn't so easy. Maybe the arrows actually have to be drawn both ways. And if we think the arrows have to be drawn both ways, then things are going to get really quite challenging. I'm going to work with an example where it's really quite straightforward. It's really quite straightforward to draw the arrows in one direction for some research questions. And that's what I can do in the time that I have for doing this presentation today. So I'll talk a little bit, really quite briefly, about an example where it's possible to go wrong, but then it's pretty straightforward to actually gain clarity and then do it in a much more effective and straightforward way. So it pertains to a number of articles that I've published that explore the impact of getting older on people's happiness. Now, it's maybe straightforward, except that in earlier research, it wasn't done correctly. There's quite a lot of misunderstanding about it. The answer that many people have about that question is perhaps familiar to you. The dominant view that researchers in the field of happiness studies, the dominant view that they have is that the relationship between age and happiness has a U shape. So as you move towards middle age, you get less happy, the middle age crisis, as we might say. But then what many people think is that as we get older, happiness starts to increase again. Okay? After middle age, as people get older, move into old age, happiness increases again. That idea is the foundation for a book that was marketed for the general public, not other researchers. It used the researchers, the research of happiness researchers, but it was a book that was published for the benefit of the general public. And you can see, right, from the title, the happiness curve, and then the arrow that is drawn in the middle, and then the subtitle, why life gets better after midlife. That's the view that many people have. And I'm about to make you a little bit sadder about what the real answer is. And what we get as empirical support for the idea of the U-shape is regression models. We get a quadratic specification for age. So the practice that many people have is to put age plus age squared in the model. And then we get inclusion of all sorts of control variables because after all, we have to control for other determinants of the dependent variable, happiness. Okay, that's what this representation tells us. If you want to know the impact of age, then control for everything else in that model. Well, let's look at the representation that I would prefer and ask, what are the antecedents of age? As I have represented the answers to that question. Which variables have arrows going from the other variables towards age? My answer is none of them. For none of these other variables do we draw an arrow from the other variable towards age. Now, why is that my answer? Let's think about it in a substantive sense. Which of these variables might affect the rate at which we get older, or indeed how old we are? The answer is none of them. We all get older at exactly the same rate, regardless of any other circumstance or characteristic that we might have. I'm going to repeat that idea. We all get older at exactly the same rate, no matter what other characteristic we have. We don't need any control variables at all to estimate this relationship, the causal effect of age on happiness. Now, of course, there are some more details here that we would need. Okay, we might need cohort. We might need period. And that becomes a fairly complicated discussion. But we don't need any of the other variables that many people we think would be needed as controls in this context. Instead, if we use these other control variables, then we're going to get bias. The direction of the arrow always goes in the other direction. So let's think about this for health. What happens with people's health as you get older? Health tends to get worse. So we're now in the situation that we already identified. If we control for health as people get older, and health we know is going to get worse as you get older, then we no longer have the total impact of age. We might have the direct impact of age, but that's not the total impact of age. And that pattern is going to be a general one. In general, as people get older, their circumstances tend to become worse. Okay? Not just for health, also for income. Unless there's a really effective welfare state, people's income is going to go down as they get older, as you retire. Likewise, with your partner, if you have one, you're more likely to lose your partner. Okay, everything's going to get worse. If we control for those other variables, we're going to get bias in our estimation, and the bias is going to go in a predictable direction. We're going to hide, if we use these controls, we're going to hide the negative consequences of getting older for people's happiness. We're going to hide them in our models. And we're going to give a false impression of happiness getting better as people move beyond old age. Here's where I told you I would make you sadder. There is the real impact of age on happiness for Italy. A model, in the first instance, a smooth scatter plot representation where we don't use any controls, no controls at all, so nothing that addresses period or cohort, it just goes down. Okay, I'm sorry to tell you this. On the right-hand side is a kernel regression where I've included cohort. Okay, and a non-parametric specification that includes cohort. But it still goes down. It's a little bit bumpier. It doesn't go down as fast, but in the end, it goes down. So this idea of a U-shape, it's misleading. It comes from using the wrong controls. It comes from using controls in a way that has predictable bias. It hides the negative happiness impact of getting older. It's the wrong criterion, and it gives us the wrong answer. Okay? We need to ensure that our controls fit this particular pattern. If they fall in the other pattern, then it's going to give us some misinformation. It's going to mislead us. Okay, I've taken too long with this angle. I now move towards what I hope will be a briefer presentation of how we would interpret our results. The typical practice is to use the language of significance. And we speak about significance on the basis of asterisks that our statistical software is all too happy to produce for us, almost by default. Okay, mostly Stata and R, and maybe, who knows, SPSS, it's going to give us asterisks in our tables by default. What I would suggest is that many people implicitly think about asterisks in tables as a sign or even a symbol that our results are correct. There's a psychology here that I think is subconscious, but nonetheless quite powerful. The asterisks are used in an unconscious way of reassuring us that our results are right. And to articulate that idea is to highlight that it's going to be something we want to try to be a bit more thoughtful about. So if I were to say, on the basis of what I presented in yesterday's presentation, yesterday's talk, if I were to say inequality, income inequality has a significant effect on life satisfaction, that is in effect what I'm doing. But it's a misuse. Okay? It's a misuse of the term statistical significance. What we need is to think a little bit more carefully about what statistical significance tells us, and then avoid that sort of construction. You can see this rhetoric everywhere. Whatever the independent variable is, it has a significant effect on the outcome that we're analyzing. It does huge amounts of damage. to the understanding that many people have about the research they've produced. One point I think is quite easy, and here's something that I think many of the people in this room would know. Statistical significance can mislead in part because it can produce results where almost anything can be significant as long as your sample is big enough. It doesn't mean it's important. Okay, so even with a very small coefficient, it can nonetheless be statistically significant. I'm not going to dwell on that. I think that's probably well understood in this room. What I want us to explore is if we have a good understanding of statistical significance, then what we would want to then do is to ask, what does the coefficient mean? And what we then want to focus on is making sure that we have the right coefficient. Statistical significance plays much too much of a role in the context of interpreting results, and indeed in the setting up of the research in terms of how it's going to be interpreted. Most people are going to think only about significance of their results, and then they are not going to be paying enough attention to getting the right coefficient in the first place. If we're going to think effectively about effect size on the basis that we've estimated the right coefficient, then we can do that in ways that, again, I think are probably well established, and I don't need to dwell on it. We're going to set the coefficient against variation in the dependent variable. We're going to think, how big is the coefficient relative to the size of the standard deviation of the dependent variable? If we have a categorical independent variable, then we can compare directly. We can compare the coefficient directly to the standard deviation of the dependent variable. If we have a continuous independent variable, then we can think about a one standard deviation change, not a one unit change, but a one standard deviation change in the independent variable, and then interpret that as a fraction of the standard deviation of the dependent variable. And then perhaps we're going to use Cohen's rules of thumb, okay, for Cohen's d in either instance. Okay, Cohen's rules of thumb, 0.8 is large, 0.5 is medium, 0.2 is small. But here as well, we don't want to fetishize those values. As the way we do with p being smaller than 0.05, we don't want to fetishize that. Instead, what we want to do is to think about it. What is the coefficient telling us? To think in those terms, we have to have been focusing on the coefficient in the first place, not the asterisks. But if we want to use statistical significance at all, then we have to be clear on what it means. It's only about extrapolation from analysis that's using sample data to the population. So then we need to ensure that we actually have data that meets the requirements. To use statistical significance, we need a random sample, partly so that we have some confidence that the sample represents the population effectively. But the key point about statistical significance is that if we have a random sample, it's not a guarantee that it represents the population effectively. So in the end, what I want to get to for the purpose of putting significance in its place is statistical significance has really quite a limited meaning. If we have a random sample, what significance might be able to tell us is whatever you see, whatever you think you see in your results, pause to consider the possibility of sampling error. That's all it means. Okay, I don't think it's usually articulated in those terms. What it means is pause to consider the possibility of sampling error. But if you've made that sort of consideration, if you've paused and you say, okay, maybe because p is quite small, sampling error isn't a big problem, we still then need to go back and ask, what do we see in our results? What does the coefficient mean? What does it tell us? If we don't have a random sample, then it doesn't make sense to use it at all. Okay. Randomness is what gives us the normal distribution as a way of making a connection between the standard errors and the probabilities. If we don't have randomness, then how are we supposed to make that connection at all? So if we don't have a random sample, then it really doesn't make sense to use significance. There's a citation that you could explore that idea with. So if you have a convenience sample, it doesn't make sense to use it. If you have population data, it doesn't make sense to use it. If you have multi-level modeling, where you're focusing on the higher level units, you probably don't have a random sample of the higher level units. Okay, now I know that time is running out. I'm going to have to skip some screens. I want to get to a couple of examples. Okay, but a couple of thoughts that move us towards some examples. I might have to save the examples towards my response to the comments that people are about to offer to me. And I want to emphasize this idea that asterisks are working at a sort of a subconscious level. They're giving us an impression of validating our results. They can't do that. They can't tell us that the results are in fact right. You can have statistically significant results that are wrong. That is not hard at all, especially if your sample is big enough. So they don't amount to validation, a license to say my results are right, they're real. Instead, what gives validation is the right research design. What we want is an unbiased estimation of the impact of X on Y. To do that, to achieve that, what we need is the right research design, the right model specification. We can't use asterisks as a way of giving ourselves assurance that we have the right results. It's the wrong focus. If we're thinking about asterisks as the goal, we're very likely to do it wrong. Now, I have a couple of examples, but perhaps I should save them. Okay, and I'm getting a sign. I'm going to save my examples. Okay, thank you.
Many thanks for this stimulating presentation. So now we give the floor to our guest. David, if you can speak
Sure.
here, perfect. Yeah. Paola. Lisa. Okay. But Paola, then Elisa, then Bruno, you have 10 minutes. Please stay with your time.
Okay, thank you so much. Thank you so much for the invite, of course. Sorry, should I have to start again?
No.
No, okay. So my name is Paola Annoni. I have a mixed background. So I have a master in physics and then a PhD in statistics. I worked in research centers. I worked at the University of Milan. And since 2008, I worked at the European Commission, first at JRC, then at DG Regio for regional policies, and then is this complicated DG with the name that is shortened with Connect on digital policies. So thank you, David, for your presentations. presentation. So I worked my short notes around the title of the official title of the roundtable that you changed. So, but I think the new title fits even better to what I wanted to say. So you changed the word rigorous with insightful, and you remove the word social, okay? But we keep still quantitative. So it's slightly more general, but it's still about quantitative research. So something to produce metrics, insights, analysis, information. And then you move from rigorous to insightful, that I think that it is an intermediate step for me between rigorous and policy relevant. So impact, because still you, and rightly so according to me, advocated for insightful analysis. I advocate for rigorous, insightful, and relevant analysis. And why? Because in the past, especially in the past 3 or 4 years, I moved slightly, fortunately, okay, there are pros and cons, but I moved from research to a more policy-soaked environment. And this might be easier from some aspects, in the sense that the analysis that we produce are not as sophisticated as the analysis that you publish and you are used to discuss and to present at conferences. But there is a difficulty of being understood, because being understood is a precondition for the analysis to be used and to be relevant and to be impactful. So, and to be ready for to be used by policymakers. That is my daily life in the commission. But then a sub-question arises. So the sub-question is the following: whether or if a quantitative research can be both scientifically solid, but useful for policymakers. Now, I don't have the answer, of course. I would like to have the answer. I would say that I advocate for an answer that is a positive answer, especially in these times of misinformation, alternative facts, and all that we experienced, unfortunately, not only in the past year, but it is a trend that I noticed in the past decade, I have to say. So you researchers, scientific researchers, need to be heard. But to be heard, you need to be understood. Now, Giovanna, Professor Boccuzzo, before in presenting my short bio, she said that my team, myself and my team in the commission are developing bridges in between research and policy making. Okay, this is an overstatement. We are trying hard to do that. Also because our analysis is always at the demand or a reply to a policy need. So this is our difficulty every day. So the answer can be positive in a sense. A solid and rigorous and insightful research can be also impactful and used by policymakers, but for getting there, it requires that there are a lot of rethinking and bridges creation to be developed. So I had this point in what makes a research rigorous, not because I pretend to teach you, it's the other way around. And also your presentation already covered a lot of what actually I wanted to say, but there is something that is very in line with what you said, because I already wrote it before your presentation, so it's here written on paper, that whatever you want to do, or whatever I want to do with my team, is the first questions for us is the what and the whys. Okay, so the what and the whys should be always the starting point for me of an analysis of a research. The fact is that in my world, in the policy world, not everything that is quantifiable is policy relevant, and I would say even more often, not always what policymakers want to measure is always quantifiable. And this second, the latter, is what I experience most of the times in my job. Just to give you an example, in order to be more concrete, no later than the other day, I was asked by my hierarchy to start thinking of a possible metric, a single one, of course, to measure technology sovereignty across the European Union. Okay, without providing me with a definition of technology sovereignty, it's difficult even for me to understand the English word sovereignty. And of course, it has to be clear, quick, rapid, and with one, hopefully with one figure. Okay, so this is what we face. So, clear. A good research, of course, but this is in line with what you said, must be clear. And also very important, and already you said that, very transparent about assumptions and limits, okay? Assumption and limits are key. The problem is that policymakers, I'm recorded, yes. Usually policymakers in the world do not care about assumptions, okay? Assumptions are really forgotten, but it's not only for policymakers, I think. It's also within the academic community. There are a lot of assumptions that maybe they are, you know, quickly listed at the beginning of the paper, and then the results are fantastic. But the results are most often what I find in the academic research, you know, they're fantastic regarding the fact that there are a lot of assumptions and they don't even refer any longer to the assumptions that are hidden at the beginning of the paper, okay, of the article. And then limits, of course, the limits, exactly what you said, the limits, these are direct, no, they're not direct, they're indirect. So you should carry out a more careful path analysis, and you have to ask yourself why. But also another thing that is linked to what you said, and it's methodological adaptability. So at a certain point you said, this is becoming, if you start and think about what you want to extract from this analysis, then you realize that it gets way too complex, and maybe it's better to split the analysis into different sub-models, each focusing on a particular aspect of that you know, overall analysis. And this is exactly what I experience every day. So methodological adaptability, so refining models and assumptions in response, in my case, for example, sometimes in response to feedback from, for example, representatives of the National Statistical Institute, or from representatives of the member states who are complaining about this and that, because at the end of the day, their idea is that the Commission will find metrics that will show how good they are and how well they are progressing in all the you know, different KPIs, key performance indicators that we have in the digital indicators. This is just to give you an example, but this is not always the case. So you have to be, I would say, transparent in clarifying the limits of the metrics that you are, and indicators that they are using to monitor this progress and these levels. So there's always a tension between scientific rigor and policy relevance. So I already said that. Of course, the fact that rigor means nuance, uncertainty, complexity, etc., is very quickly forgotten. But in the policy context, there are two main, I would say, constraints or difficulties that we face, and it's simplification pressure. We need to be simple, okay? Despite the fact that we are asked to provide something which is super complex, I tell you, it's super complex, they ask for simplification. So for example, composite indexes, they love composite indexes, regardless of the fact that they are built in a statistically solid way or whatever. There is a lot of attention from the media, and then the attention of the media, of course, pleases the commissioner, the director general, of course, provided then the ranking that you provide does not contradict what the different member states expect. And given that it's a ranking and the ranks are not mutually independent, there is always someone who goes up and someone else who goes down. And then we have I'm not joking, we have phone calls, not directly to us, but to our director general of the different ministries, complaining very hard that we are not providing something solid, something rigorous, and everything is mistaken. And of course, the director general, what does he do is he calls us. Okay, so simplification, it's very, very difficult. And then misinterpretation risk, which is connected to what you said. So, no, sorry, path forward, I don't know. There is not the simple solution. I finish. Okay, given that I I constructed my intervention as an intervention to maybe to propose something new or something different for the new SEER, for the new social indicator research, given that we have here the honorable editor-in-chief, is that we need bilingual researchers. So we need researchers who are scientifically solid, very well prepared from the statistical or mathematical point of view, but you need also persons, I wouldn't say like me, but persons who are in contact, constant contact with these difficulties and with this reality, okay? And so bilingual is one of the key that I would like to put on the table. And then another thing is that, but is this more personally, it's the power of data visualization. So charts and figures are not only at the core in a paper, they should become an essential part of that. So I would end with this sentence that I would say that rigor or insightfulness without relevance may be the quiet crisis of academic research. Thank you so much.
Paola? Okay. 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 Go. Thank you. Can you hear me? Yes. Okay. Thank you very much. First of all, thank you for the invitation in name of GLASS, the lab that I'm representing today. We're really glad to be part and to be able to say our point of view, to share it. And we also thank the editorial that was mainly the base of today's talk from Professor Bartram. And we are really particularly glad to see an open and transparent description of what an editorial board would are the expectation. And we really hope that that can be of an example for other journals as well. Because it also calls to and highlight that good research is not only about mechanism, but it's also about good theory and thinking about the mechanism behind what we are studying. So from as early career researcher, non-tenure track researcher, that's really good for us to see that journals are moving towards that, clearly stating that in written words. So while we were discussing the editorial together, just two main points raised. So that's what we would like to share with the audience and also with speakers today. The first is regarding the construction of causal evidence, because it is certainly true that building persuasive causal evidence is challenging, but it's also the best outcome we can look at as a researcher. But it's challenging not only because of methodology and theory, but also because of data availability. In many countries, let's say in Italy also, longitudinal data or experimental data are often limited or even absent. And what we do have, if we want to have good data, representative data at national level, or also talking about politics or policy relevant research, if we want to look at minorities, if we want to look at smaller areas, we only do have cross-sectional data, which are stable, which are good, which are representative, but still cross-sectional. So that's why it's a good point that the editor was also looking at that, say if you are explicit and if you really think about causality, then you can also work on cross-sectional data, but because they really do give sometimes descriptive foundations for what is used in causal studies. Like a lot of controls that we do use using longitudinal data comes from descriptive analysis. So that's also like a sort of balance. Bigger samples, representative, but cross-sectional. On the other way around, we do have panel data, but if you want to deeply go to a research question that it's really specific, then we miss numbers. So it's a sort of balance. And so the point is, if we want to promote a causal thinking, even when using cross-sectional data or experimental data, and if you want to do that, in which way we can do that as a scientific users or in general as a community. So that can be a big reflection than more than a question mark. And the second point raised is connected with the statistical significance that you were mentioning during your presentation. We really truly appreciate the switch from statistical significance to a substantive, that's essential point. And at the same time, that point can also be seen from another perspective, from our point of view. And it's the perspective of a strong bias towards publishing only positive, significant results. So we do share the feeling that if your method is really rigorous, you do have good data, but nothing emerged in terms of statistical significance, then we do share the feeling that you don't have something to be published, but actually no results may be results. And this is something that maybe it's overlooked in scientific publications. So it's a sort of bias. It's even the so-called hacking that you mentioned in the editorial. So maybe it's a point of discussion. But while we were reflecting on this issue, this naturally leads us to consider overall the broader ecosystem of that supports scientific research, which is the peer review system, which is connected also to what you were mentioning in your presentation. So we are fully aware that finding willing and qualified reviewers, it's a big work today. It's really heavy work. You know something better than us, I guess. We also share the impression that reviews are getting shorter, and then sometimes reviewers are not really confident with the topic they have into hands. And that has an impact on the quality of research. That has an impact not only on our careers. I mean, I'm talking in name of class, but in general, but it's also on the quality that we publish, actually. So, of course, this is a broader concern that goes behind this table. It's more, and it involves us as a community, as authors, as reviewers, as editors. And that's why we take the opportunity to have Professor Bartram here in this table to raise this question, because it's really something that it's happening, and so the question is, if your journal, if you as an editor have thought about it with the community, but in a broader sense, so talking about also other people in this room, but talking as a community, what we can do to strengthen this peer review process to maintain high standard research quality. So how we all can just participate into that discussion from that point of view.
Thank you.
So thank you.
Well,
is it green?
It is green. First of all, let me thank again Professor Bartram for having accepted the invitation to be here and to discuss about these very important but often overlooked issues. I will focus on causal inference as expected, and my points will try to bring together substantive, epistemological, and institutional factors that I think are interconnected. So the first point is something more substantial. So epistemological also. In some situation, we might not have a good theory that guides the labeling of variables as controls, confounders, or mediators. Of course, these might arise very often in cross-sectional analysis, where you measure at the same time the variables, and so you may not have the possibility to put the time dimension on the problem. But even in longitudinal studies, let me make a simple example from my research. If you have to estimate the effect of age at first birth on well-being at later life, there are good reasons to believe that education may be a control, because it may affect the age at which women, for example, have children. But age at which women have children may also causal interaction of the studies and the educational career. So it may be also the other way around. So in those situations, it's unclear how to treat these variables. So one pragmatic approach that I have also used in my research is to try both specification with and without the model, the control variable, and if things remain stable, okay. But otherwise, we are in a difficult situation. So how would you suggest dealing with this situation? The second situation is one where we recognize that these variables are controlled. We submit a paper as a researcher, but then, as we all know, and as it was also pointed out before, editors and reviewers are not always aware of these issues. So again, let me make an example from my recent experience. We measured family life courses related to having children, being married, divorced, from age 15 to age 49. And the outcome was, again, different measures of well-being later in life. And we pointed out in the paper that we only control for something happening before age 15 because we didn't want to mix with something happening after these events, childbearing and marital relationship were happening. But there was one reviewer that insisted, oh, why you are not controlling for such important variable like current income, current partnership status, health, as he also pointed out. Well, in the first round of review, we mentioned papers about wrong controls, and we tried to justify theoretically only, but then he or she insisted. And in the end, well, we applied the pragmatical approach in the text. Of course, we maintained our correct specification, but in the appendix, we also showed what happened controlling for those, and hopefully, in that case, didn't happen any change. So the question here will be similar to what Elisa was saying. So how we can make sure that editors and reviewers are also applying this kind of guidelines. And of course, an editorial can be useful, but my question is it working, first of all? Because sometimes I think that people, as reviewers, because we have many commitments, don't follow strictly the guidelines of journals. So maybe it's not enough. Maybe as members of the academic community, we can do also something else. I don't know, through academic associations like the ISA or other, but also as professors. So I think that one of the problems, as you also mentioned, is the way we teach statistics, even in quantitative field. So we start with the method, not with the goal. This is the method, these are the properties, these are the assumptions. Okay. But we should start with the goal. If the goal is prediction, then what kind of approach we should follow? And if the goal is causality, maybe we should follow another approach and other methods. So we should also try to make a change in the longer run through our teaching programs. And I will conclude with a possible way to save the wrong control, let's say. So as you also mentioned, adjusting for a mediator, intervening variable, may explain the effect. And some people say that causal inference is not enough, so we should not stop at estimating a causal effect in the right way, so not adjusting for wrong control, but we should also explain why we have these effects, because these might be also important for policy justification decisions. So what do you think? We should push researchers not only to correctly estimate the baseline model and also go ahead in interpreting this model. And this can be a way to also engage those people that are used to throw all these predictors of the Y variable in the analysis. So the guideline in that case would be something like separate the model with and without the mediator, and this may actually bring even more information. So thank you.
So maybe we have time for a couple of questions if there are from the audience. Or we can start with the answer from David. Microphone, please. Okay, please.
Okay, thank you to each of you for those comments. I think you've made my life fairly easy. You haven't given me anything where you've identified disagreements with what I said. You haven't given me anything where I'm going to disagree with you. I mean, I think you've posed some pretty challenging questions. Don't think there's easy answers for much of what you've said. I can start with endorsements of the idea that research should be relevant. And in particular, the idea that one of the ways to achieve that is to present results with visual mechanisms. That's become central for me. I'm as guilty as anyone else of not doing it for an extended period. When I started to explore the so-called U-shape, then it was a sort of a foundation for thinking, okay, what is the shape? And I'm going to present my results by actually showing shapes. So it's made it very effective for me, very sort of enlightening to adopt that. And I think those 2 points are combined. I can appreciate the kind of the way my life is easier as an academic researcher. I don't have to make the kind of efforts to produce things that are articulated in simplistic form. Right? If I'm going to publish a journal article, I can get away with not having to do that sort of work. But in the end, I agree that's entirely necessary if you want the research to be relevant. On the topic of peer review, and this is something that you both asked, this is where I think I come up with very little. Certainly nothing where I can say, here's an easy solution. There's no shortage at all of reviewers that don't know anything more than what the authors know. And maybe there's a lot of work being done by people who don't know an awful lot. And then it turns into a situation which is very challenging for editors. I have been in situations where I have seen editors simply endorse whatever the reviewers say. They turn it into a vote. Right? If the reviewers say this should be published, they publish it. If they say it shouldn't be published, they don't. And I'm looking at the reviews and I'm thinking, why are you relying on these reviews? So in effect, I'm endorsing what I imagine you already know. The peer review situation is decidedly imperfect. And then in a situation where there's ever more manuscripts being produced, it's ever more difficult to get good colleagues to agree to review, to take on the reviews. And this is where I have to say, I don't have good solutions. I don't know what to do apart from sort of embracing the longer term project of trying to improve people's, if we can say, statistical literacy, quantitative literacy, understanding. I mean, if nothing else, that idea, it serves our interests. There's a need for us, right? There's a need for the programs, for the departments here, for the work that we do. I think it's a long project. I do not have suggestions for how we can sort of move from A to B in a way that will be in a much better situation in 5 years. I think if anything, we're likely to be in a worse situation. Just massive numbers of manuscripts and not enough people to review them. And then we get too many reviews where you can't rely on it. So that's where I'm sort of pessimistic and I don't really have a good suggestion for you. I would like to think that the editorial will maybe have impacts beyond just social indicators research. I have circulated it. And I think I mentioned there's a Google group of journal editors And I've posted, I became a member of that group partly for the purpose of trying to circulate some of these ideas. It's a very big group. It's not just social sciences. So it's not, I can't just sort of say, I don't have a targeted group, right? Social sciences where there's a lot of quantitative research going on. I don't know of a group where I can sort of, but it's maybe we say it's still early days and maybe it will have an impact, but I think it's going to take an awful lot more work. I might come back to data availability, cross-sectional. I've got some specific ideas about how to address that. If we come to Bruno's comments about the sort of specific ideas for dealing with an issue that I raised, right, and you've encountered it, and I know that you think about it as well. You don't need me for that purpose. It's, as I said, it's possible that the arrows that you would draw, they would go in not just one direction, but in fact the other. And then what you suggested is the way to deal with it. Try it both ways. If it doesn't make a difference to the coefficients, then at least you can say, it actually doesn't matter which decision I make. I know that the decision isn't simple and straightforward, but in the end, it doesn't have an impact on the coefficient. That's what I do as well. It has the virtue of reinforcing the idea that it's the coefficient that matters, not the significance of the result. Right? So the more we highlight the need to estimate coefficients where we can make a case that we've tried to mitigate bias, right? We've tried to address bias so that we have the right coefficient. The more we do that via discussions of that sort, I think that's likely useful. I also think it's useful to do what you've described in the sense of doing the analysis where the control is used, but you're doing it in your manuscript in a way that says, I'm not using the control for the purpose of estimating the total effect. Instead, the reviewer has told me I need to have this control. So here it is, here's the result that includes the control, but then it's interpreted correctly. I think that is also really useful. And I'd like to see an awful lot more of that. I would prefer to have reviewers having a better understanding so that they're not simply saying, just use more controls, right? More and more controls. And there's plenty of reviewers that do this. There's reviewers that think, there's people, scholars that believe that the more control variables there are in a model, the better that model is. And of course, that's just not true. And there's better understanding, but we can perhaps improve people's understanding about it by responding to situations like that. We might not convince the reviewer that the control isn't needed, but we can put the control into a different model and then interpret it correctly. And that's okay. It means trying to do it in the context of a word limit for a journal, right? You've only got 8,000 words, you don't have endless space, so it might be challenging, but if it's possible, I agree, that's exactly what we need to do. My overall sense, and I think this sort of reinforces the observations you've made, my overall sense is we are not in the position we want to be in terms of the quantitative understanding, the statistical understanding that many people out there in the world have, even active researchers, employed researchers. The level of understanding is not where we would want it to be. But once again, we can try to draw a silver lining from that observation and say, well, there really is a need for more work for departments like this, for people like us, perhaps, to try to push it forwards. And that's what I spend my days doing. I spend every day thinking about these issues in connection with the endless flow of manuscripts that I receive. And I try to give decision letters to authors where I don't just say you're doing it wrong. I try to explain. I have large numbers of documents where if I see an author, a manuscript that makes a particular, what I'm going to say is an error, then I've got a document that is going to explain the error. Okay, it's really, so my decision letters, even for desk rejections, they're really quite long. I'm not writing separate ones for every different manuscript. They're all pre-prepared for the different situations that I face. When I'm trying to engage with that project of improving the level of understanding. And that was the goal of the editorial, and it's something that I take seriously. And so I'm grateful again for the opportunity to come here and talk about it and for your attention in this particular session.
Thank you very much. Other questions? You know, David, I'm always very worried about the moderators, the moderator effect. How do you think we can introduce we can consider, for instance, in a path analysis, it's very difficult to include interactions, but the world is complicated and interactions exist. How do you think is the best way to work in presence of interaction effects?
So from yesterday, the same idea, that's okay. So to address interaction effects, it introduces all sorts of complications. In effect, what I had on the screen with the two diagrams, the simple one, control for other determinants, but then we want the more complex one, with the arrows that go between the different independent variables as well. I mean, it doesn't look like path analysis, but of course it is path analysis.
Mm-hmm.
And it could be reconfigured in a way where it was clearer, especially once we've got clarity on the variables we need. And so then we can have a diagram that looks like path analysis, which I think is very useful. But then, as you say, once we start to think in terms of interaction effects, we can draw the arrows, okay, so that we've got an arrow from a variable that we think of as a moderator, but then we draw the arrow not to the other variables, but to the main arrow that we're looking at. That's useful, but it conveys an awful lot of information that then needs to be extrapolated and managed in the process of the analysis and explaining it to readers. And what I would then suggest is that interaction terms as a way of gauging the impact of moderators, I think that is more usefully addressed not through interaction terms in the model. I think it's more usefully explored via constructing separate models that corresponds to our sense of what is the moderator doing. It's telling us about the different values of the coefficient for the different groups that corresponds to the levels of the moderator. And what I would then want to do is to construct different models for the different groups.
Yeah.
It could then be articulated via a model that uses an interaction term, but only once the more sort of straightforward presentation of that idea is in place via the separate models.
Yeah, it's true. Okay, we can continue our. Sorry, Bruno.
I have thousands of questions, but we can talk later. But one, I think, issue is artificial intelligence, in particular, large language models. We all know that this is very useful in our research, in helping coding and writing text, reviewing text, etc. What is your position, and maybe the position of the journal on this? Because sometimes the line between using standard tools like Google search and more advanced modern tools is blurred, and journals are now starting to ask authors to declare that they use artificial intelligence. So what's your view on this issue?
Okay, I mean, that's a big topic, so I have to be brief about this. In part, my thinking about that topic is made easier by the fact that it's a journal that's owned by a particular publisher, Springer. And then it's Springer that has the policies on use of artificial intelligence as an author. Okay, so if the manuscript wasn't written by the author, it was written by somebody else or something else, then that has to be declared. And Springer currently does not allow large language models to become authors. So I'm in a position where I can say the journal doesn't accept that we're going to have a manuscript that was written by a large language model. Of course, the question is, can I tell? Do we know? And sometimes we do know. Okay, and if I think that a manuscript was written more by AI, a large language model, and not by the, and if I have enough confidence that I would be able to demonstrate it if challenged, I'll reject the manuscript. Okay, it doesn't meet the publisher policies. I will also certainly reject it if it's clear that the results are wrong. So I recently received a manuscript where I'm looking at the text and I'm looking at the table that the text corresponded to, and they didn't align. So I wrote to the author and I said, well, you've got your table. It was qualitative comparative analysis. It wasn't even a quantitative thing. Okay, it was a truth table from qualitative comparative analysis. That's sort of the Boolean thing from Charles Reagan. And I said to him, I'm reading your text, but here's how I would interpret your table. So what's going on? And he wrote back and he said, oh, I used a website. So I said, you're done. Okay, I'm not having your manuscript. Because it wasn't written by him and it wasn't right.
Not even revised by him.
Not even
Yes.
looked at, not even investigated to see that what was produced was actually what he had in mind. So if somebody makes it easy for me to reject a manuscript because they've done something like that, that's great. It's less work for me. I don't have to find reviewers. Okay, I only want to find reviewers if I'm confident in the manuscript. So I'm pretty uncomfortable with artificial intelligence, large language models. I think that authors that use them, my sense is, and I hope I'm not talking about like my sense is that somebody who uses them, that they likely don't really have much of an understanding of the results that they're producing. Okay, so I've got difficulties with it. I also have difficulties partly because I've sort of hinted, or maybe I've said, I think we have too much research already. We don't have enough good research, but we have too much research in general. I'm not in favor of people using large language models to produce more and more research. What are we supposed to do with it? We can't find reviewers for the research we have. So I would prefer, it's personal preference, okay, but I would prefer that we have less research that is more careful research. And I'm not convinced that large language models are giving us more research that is also better research.
And more impactful.
More impactful as well.
More impactful.
More impactful as well. Yeah. More relevant. Yeah.
Of course, it is a matter of how we use
Of course.
language model. It can be a tool that helps in several aspects of the research, but of course, if it generates fake result.
Yeah. So something to improve the language. I am in favor of that. Okay, they have to get submitted in English. Not everybody's first language is English.
Yes.
Make it easier for me to read. I have no problem with that.
Okay, provided it is correct.
Yeah, exactly.
Okay. Other questions? Okay. Now in a couple of minutes, the lunch is ready on the right in our garden. Okay, thank you again, David, for your presentation.